Now we've added some questions to the exit exam. So we're going to give you a few more problems to show you what the work would be like to allow you to earn full credit. Now there's only 25 questions total, but again, this is a review stressing strategy and the work needed to get full credit. And that's what they're saying here. And again, if you don't show work, or a lot of work, you might want to write a short explanation to justify your answer. And this is part of a practice exam your lab instructor may have given you. So here it is. If an object is propelled upward from a height of 32 feet at the initial velocity of 64 feet per second, then its height after t seconds is given by this formula, where h is the feet. After how many seconds, which is t, will the object reach the height of 96 feet? So what you're asked here is to put in this basic formula "96 feet" right here. That's your height. So you want all of this to be positive here on this side. So we're going to take this negative 16 and bring it over here. So this becomes now a positive 16 t squared. We're going to transpose that as a negative 64t. And then this comes over as a negative as well. And that will become a positive, subtracting 32 from here, 32 from here. So that would be a 64 as well. So there's our new quadratic formula. Now, or equation, I should say. And I see each is divisible by 16. So that's the first thing I'm going to do. Now you could put this into the quadratic formula with a being 16, b is this, c is this. But you could make it simpler by just dividing everything by 16. So this then becomes t squared. This becomes a negative 4t. And this becomes a plus 4 equals 0. So this factors nicely now. So that's t, 2, 2 minus minus. So t is going to equal 2. We get two of the same answers. And you have now given the work needed to earn full credit for this particular answer. Now, in example 2 here, we have a rational equation in which there are fractions. And the rule is get rid of the fractions by multiplying each term in the equation by the lowest common denominator, which is this. These are conjugates, and this is the difference of the perfect squares that factor into their conjugates. So we're going to multiply each term in this equation by our lowest common denominator, m plus 2, m minus 2. So here, these cancel out with this one. So we now go 9m plus 18. So once again, multiplying each term, there's 3 terms, by the lowest common denominator. So we get rid of our denominators, all become a 1. So I'm going to put this negative right there and make that a positive. This is okay to do. Now we're going to take out this term. So what's left here is this. So m times a negative 7 is a negative 7m. A negative times a negative makes us a positive 14. And now this cancels completely, so all we're left with is a 4. So a much easier equation, and this is the work you need to show. Now, when I checked the finals, this was actually a similar problem. Students didn't show the work. So even if they guessed the right answer, they would only get 1 point out of the possible 4 points. You need to show this work to get credit. Now we're going to group like terms. This is a 2m. We're going to group this and this now, and this becomes 32. 18 plus 14 is 32. And that equals 4. We're now going to subtract 32 from both sides, and this becomes a negative 28. And we get 2m now equals a negative 28. We divide both sides by 2. We get m equals a negative 14, which is letter C, which is the answer of example 2. And this is the work to support your answer for full credit. This is a new item that was added to the test and wasn't in my earlier preview of the test. So we want to go over this in some detail. So let's check it out here. We have here a fixed temperature resistance R of a wire varies directly as the length and inversely as the square of its diameter. Okay, so again, 2 formulas for direct variation. We have y equals kx, and inverse variation we have y equals k over x. So this is a combination of the 2. Notice the k's are always in the numerator. So we can change the y to an r, the resistance. And again, we need our k to its length, which will be L, over its inverse, the square of the diameter. So there's your basic formula. So they're telling us the resistance is 1.08 equals K. Our length is 270. And our diameter is 1 squared, which is just 1. So we can leave that as 1, or just leave it like that. We don't need the 1 there. So what will K be? Well, here we have to divide now both sides by 270. And we get K equals 0.0 0.004. So now what I'm going to do in this original formula is put my 0.004 to replace k. So I'll erase this here, and you're going to put there 0.004. Your new length is 1800, so I will replace that with 1800. And the new diameter is 4 that we're going to square, so I'm going to replace this with 16. Now you could write it out. That would be showing the work here. So when I put that into my calculator, I multiply this times this, divided by 16, I get 0.45. So D is our answer. Now in order to get that, I had to show this original formula and what K was. That's critical. Now once you find your K value, you replace it there, put in your new length, divided by your diameter squared, and you get this as an answer. This is the work you would need to show. You didn't have to write that. That's a little bit of background. Now, for this, we're asked to rationalize the denominator. So I took it to the first step where I separated each of my numerator and denominators into separate radicals. Now, the strategy was, is there a perfect square factor? And by the way, all of these are going to end up being negative. So there's my negative sign. And we said the strategy for this was to put them into perfect squares under one radical sign, and whatever is left over under the other. So this is going to be 25 is a perfect square, and this would be a 2. And x squared would be a perfect square, and x would be left over. And then here, y to the 4th is a perfect square, and a y would be left over. So this is going to convert to, and again, all this is negative, 5x here. And this is going to be y to the 2nd. And then we still have the square root of y here. And over here we still have 2x under the radical sign. Now, to make this a perfect square, that is to rationalize it, I have to multiply this by 1 in the form of the square root of y over the square root of y. This is a 1. But now I get the square root of y times the square root of y is the square root of y squared. Remember, all this is still a negative. So this comes out of here. The square root of y squared is y, and then makes this y to the 3rd then. So I have rationalized that denominator. And then now this is still just 5x, the square root of 2xy. Now I have rationalized this denominator. And which one do we have here? It looks like letter D here. Negative? Yes, that's good. Okay, we're going to do this one now. And what they want us to do here is to solve this equation that is a radical equation, because it has the radical sign. Now the rule for that would be isolate the radical. by bringing this term over to the other side. Now, for this one, that you've isolated the radical, and that's an even root, are we allowed to have the radical of an even root equal to a negative number? And the answer is no. So this cannot be true. So for this one, there is no solution. Now, there are others that might be on the test. And you might say, well, suppose if this were a positive 8, this was a negative here, how would we go about solving that? So let's do that one just in case. So that one there was no solution. But if this were a negative, and we had the fourth root of t minus 2 equals, now this were a negative, on this side it would become a positive. So the rule is we would just raise this to its index number power, and that would just become the radicand. And then we would raise this to that same power. So our answer would be then, this would be 8 to the 4th, whatever that is, plus 2. So that would be the pattern to solve it if this wasn't a trick question by having a negative 8 on this side where there is no solution. Now another one we found on the test, on that exit exam, was one like this. It looked just like that. Let me write it out here for you. X plus 9, the quantity squared, equals 12. Now, you could expand this, integrate that, put it in standard form, and then use the quadratic formula. If it didn't factor, this doesn't factor. But you could do it this way. This is the easier way to do it, where you're just going to take and use the square root principle, where you take the square root of this side, then that just becomes the radicand, and plus or minus the square root of 12. Now we have to remember that the square root of 12 is the square root of 4 times the square root of 3. And the square root of 4 is 2. So this will become plus or minus 2 the square root of 3. Now we transpose the 9 as a negative 9, and it disappears from that side. And there's your answer. And isn't that the easy way to do it? So it's going to be 9 plus or minus the square root of 3. And it looks like it's letter B there. Negative 9 plus or minus 2, the square root of 3. And there's the work to show it. You're using the square root principle. Now, again, you need to show the work to get credit for the answers. Now, in an earlier lesson, we had mentioned this. And for this, when they ask a question like this, they want to know, what does your discriminant come out to be? B squared minus 4AC. Well, if this is a perfect square under here, and let's say you end up with a 16, then the square root of 16 is 4, you're going to get 2 real rational answers, because this is plus or minus. If this comes up to be like 17 under there, you're going to get 2 real irrational answers, because 17 is irrational. If this ends up being a 0 under here, then plus or minus 0 doesn't change your answer. you only get one rational solution. Now, if this is negative under the radical sign, then you're going to get two different imaginary solutions. So you need to, first of all, identify what is your A, B, and C here. So you have to put this in standard form. So now that it's in standard form, A is 5, B is -6, and C is a +3. So we're going to get plus or minus B squared, which is -6 times -6 is 36. This is all under the radical sign. Minus 4. A is 5, and C is 3. So this will be plus or minus the square root of 36 minus 20 times 3 is minus 60. So what will you have left under the radical sign? You're going to have a negative value. If you have a negative value under the radical sign, you're going to get two different imaginary solutions. Now, you've shown the work. You're just going to go here plus or minus. This is going to be a -24. That would be enough to indicate that you're going to get two different imaginary solutions. And to figure it out, you have to know the discriminant. Okay, our last one. And notice that on the practice, they give you the answer key here. So it kind of tells you the answers, so you know what the answers are. But again, the answers are only 1 point. You need to show the work to get your answers. All right, let's take a look at this one. So this is the information they're giving you, that the log of 2 is this, and the log of 3 is this, and they want you to use this information to find out what the answer is when you have log base 9 of 27. Now, normally, we would convert this using the change of base formula, which is log of 27 divided by log of 9. Now, if you put that into your calculator, you're going to get one of these answers. But you need to show the work using this so that you can get full credit. So we have to think of what is this. Well, they give you the log of 3 here. And what is 27? Well, remember that's going to be 3 to the 3rd power, and the log of 9 is 3 to the 2nd power. And we have values for this and for this. So what would it look like to show the work to support your answer? And there are a couple of ways to do this. For instance, log of 27, as we said, is 3 to the 3rd power, and 9 is 3 to the 2nd. So putting it into a log form, we would take the 3, bring it out in front, and multiply it by this value of 3 up here. And for the 9, we'd take the 2, bring it out in front, and multiply it by this. Now that's one way to do it. Now another way of doing it would be is put this in its expanded log form, where it would be log of 3 plus log of 3 plus log of 3, all divided by log of 3 plus log of 3. Now, log of 3 we know is this. So you would be writing this number 3 times. So multiply this by 3. This, you're going to write this 2 times. Now that they've put in the log of 2, you didn't need it here. For the one on the exit exam on one of the forms, you did need the 2, but it was done in this way. And hopefully through your practice, you will get the skills needed. But again, you must show the work to get full credit. And good luck on your exit exam. Oh, we didn't tell you the answer. The answer is 1.5. And again, if you put this into your calculator, log of 27 divided by the log of 9, you get 1.5. If you do it this way, you get 1.5. Works out the same. But again, they're giving you this information. They wanted you to use this in the work to illustrate how to get this answer. Now that'll wind us up.